Let's take a look at some single-phase motor name plates to see what kind of information we can get off of them. So take a look at this first one right here. It says it's a single-phase motor right here, and so it's saying low voltage and high voltage. So that means we're running at 120 volts or 240 volts or somewhere in that area. There's T1, T2, T3, T4, T5, and T6. So that's a 6-wire motor, and we can wire it differently here if we want to go in low voltage or high voltage, clockwise or counterclockwise. All right. The nameplate here tells me that I have a service factor of 1, so my service factor amps are 13.2. So if we wanted to go ahead and wire this up, you're going to see 6 wires coming out of the motor. Okay. And if you wanted to run, let's say, counterclockwise, and you wanted to run high voltage. So let's say we're going to run high voltage and we're going to run counterclockwise. Okay. So we'd be looking at this chart right here. And so we have, we would interchange leads 5 and 6. So if we're going to do this, so this is shown as clockwise, so it says 4 and 5, but because we're running the other way, we are going to interchange 5 and 6. So we're going to go 4 and 6. So according to this, 4 and 6 would come here, and line 1, we have line 1 and line 2. So line 2 would come here, and then this would get wire nutted together and taped, and then therefore we have brought a line to 4 and 6 instead of 4 and 5 because we're going the other direction. The first one goes here to line 1, so that would have got wire nutted right there, and now we brought our high voltage line 1 and line 2 there, 240 volts there. It then says we would tape the remaining ones here, 3, 4, and it says 6, but we've interchanged it, so that would be 5. So these ones right here would all just get put together, and they would get wire nutted and wrapped, and then all this right here would get tucked into the enclosure on the motor and capped, and then you would have these lines coming out, and you could power up this motor, and it would run in high voltage, and it would run counterclockwise. On this next motor here, we're going to take a look at. So this is a single-phase fixed rotation, and we're assuming that this is going to be it is single phase. Yep. So it's listed here by volts: 115, 230, 460. Now 460 single phase is not really that popular. You don't see it quite as much as you would see 115 and 230. Okay, so that's why we used high voltage here. We're talking about 230 or 240, not 460. But if we wanted to see what else was going on here, this has a thermostat lead, so they were provided that we could connect these 2 leads and it would have a thermostat. There'd be some type of thermal protection on this motor if it ran too many amps. Okay, and the thermostat rating here is giving us how many volts and amps. So you wouldn't think that the motor is designed to probably pull about this many amps. If you exceeded this many amps, then the overload would trip, the thermostat would trip the motor. So I'm gonna guess that this is about a 230 volt 3 amp motor or a 115 volt 6 amp motor. Notice that these ratios are all the same. If you double the voltage, you cut the amps in half. If you double the voltage, you cut the amps in half. So just understanding that power is equal V times I, I'm gonna just pick any one of these. I can pick 230 times 3. Okay. And if you get 230 times 3, you get 690 watts. Okay. Now, we know that 1 horsepower equals about 750 watts. So you can tell that this is close to a 1 horsepower, just under a 1 horsepower motor. Okay. And so a 1 horsepower motor, you could then go and size your starter and overload. I'm sorry, it's a single phase. You would size your contactor to turn on your lines, whether you had it wired up as low voltage or high voltage, and you know the electrical characteristics based on the fact that it's about a 1 horsepower motor drawing this many volts and this many amps.